All right. Hello, everyone. Today is Tuesday. Today is Core Protocol Sync. We have several people here. We'll give updates on the core protocol development specifically from the last week and going forward. Ozgan, you're first on my screen. Do you have anything to share?
Okay. No, I don't. I'm just following the developments on the core protocol side and try to reflect them on the Farmer desktop app. I don't have anything for core development.
Okay. Did you try to update the Subspace to latest snapshot on the desktop Farmer?
No.
To like the latest Git committed set of the official release to see if it works?
Right. Today there are some other bugs I need to take care of. I will try tomorrow morning.
Okay, there is a chance it will actually work, but we need to like verify that it actually connects and syncs and everything.
Yeah.
Okay.
What are the other bugs you have ahead of that, Oskin?
Let me check. I have noted it in here.
Are they like critical bugs, or are they just like UI improvements, like tweaks?
Some of them are tweaks, some of them are critical. Most of them were related to the PRs that need to be merged that were submitted already before. Trying to merge them so that I can work on the latest things.
Okay. Can you shoot me a message on Discord that just outlines like what you see as the steps that you need to implement before you can merge in the latest snapshot and what the estimate is on the timeline for that?
Of course.
Awesome.
All right, Red, you had first pull request this week. Would you mind sharing?
Yeah, cool. Actually, two of them, but okay, let me go with the first one. Give me one second. Okay, so the first one is mostly a kind of like a primitive that I've thought of that could sit underneath to actually just validate finality proofs and nothing else beyond that. So basically, given a set of authorities, we take the justifications for that block and we just simply validate them and do not store any kind of state as is. And okay, the main following through the commits would most likely give you an idea as to like how exactly this is set up. But I'll just quickly take you through like the basic idea, like how I'm thinking about this. So we have a chain traits that represents what we have for Polkadot or Kusama, for example. Since the with substrate, the traits could be configurable, the types could be configurable. So we'll end up having to have different types for different chains that we are importing for. For now, Polkadot and Kusama, they have a similar types underneath. But if we want to validate for someone else for a different chain that has a different types completely, which is very possible. So in that sense, we'll not be able to validate them. So this is kind of like an abstraction that we have that represents. This is a kind of like a taken up most of the code from our existing substrate, the definition itself. So it should look pretty familiar. And post that, what we have here is this is the main one that actually does verify the finality proof. So the finality proof is basically a bunch of signatures done by an authority set that was elected in the previous era, right? So, and that is the state that we have to track for every chain. So what is the authority set for this particular era, and what will be the next authority set that's gonna come in? And using once we know these authorities, we can pretty much verify their signatures as well as weights that are assigned to each authority, so that we can justify that the finality has done. So the justification would be straightforward, like just a bunch of signatures to verify, given that we have these authorities, public IDs, right? So, and what it does is once we have the justifications done, this is the most primitive one, and it just gives whether it's a valid justification or not, and that is pretty much it. Uh, the most of the things beyond are basically just some helper functions for us to write better tests in the next coming PR. Uh, the 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 next PR that actually accompanies and ties up with what we're working with the feeds palette and how we actually validate the finality proofs is the second one. Um, I'm just going to skip through the basic palette implementations. It's pretty much similar to the substrate palette. I can talk a bit more about how I've thought about the palette implementations, but the immediate step would ideally be that we have an implementation here, a definition of a trait, something we are calling it as a feed validator. A feed validator basically just takes in an object as bytes and a proof. I've specifically did not try to put any hard types into it because of the chain implementation, different chain implementations that we have at a later time. So I just took an abstract vector or a slice of bytes here, and and the connection is pretty simple. Like we have a that is a defined in the feeds palette, and we have our finality verifier palette that actually implements that. Um, Let me go here and yeah. So the implementation, the implementation is that how we define underneath is basically we define the chain types by kinds of what kind of a project it is. Like right now, Polkadot-like projects have a block number type is U32 instead of U64. But if you look at maybe a different project like Akala or someone else, they would ideally use U64 if I remember correctly. So that's the main difference as to why we have that abstraction. And whenever we are initiating a new chain that we need to validate for the first time, we end up uh, uh, giving a hint that says like whether this is a Polkadot type, or if we need to add any custom, then we would ideally have to do a runtime upgrade after adding the necessary types here. But for now, I just went with Polkadot because that's our initial first chain that we'll be onboarding. And yeah, so the validate finals block is pretty much here, pretty much does that. Like since we know the chain that we're gonna implementation of the chain that we have, it just defines a bunch of decoding examples here, like decoding a block, decoding a header, and decoding a finality proofs. So what we ideally expect the extrinsic to get in is a block, which is finalized. Along with it is a finality proof for the same block. And these are pretty much the exact structures that Substrate RPC gives out. So relayers can pretty much call the RPC and then simply send it to our RPC here. It should be as simple as that. So once we decode a bunch of these and the actual verification starts out here. I'm gonna quickly run through this and so that I don't take too much time here. But so this is a one. Like we do a bunch of decodes here, scale decoding, and then a bunch of checks to ensure that we are always progressing, like we are moving in the forward sequential order. And this is where we fetch the existing current authorities that are defined for this era. And then we verify the justification using those authorities. And what we do after is that every time a new era or a new authority is going to be changed in the next era, Substrate does add bunch of hints in the previous era itself when the authorities are elected. So what we do here is that we try to see if this particular block or the block header has those hints given, and if they do have them, then we pretty much add them into the new set. So what happens from this point is that every time a new block that comes in will have to be signed by this new authority set instead of the old ones. Yeah, so that's pretty much it. If you have any questions, let me know.
Makes sense to me overall.
Can you give us a little more on what the current stage is, what the next steps are, and how this interacts with the relayer that Serge is working on and what he needs to do?
Yeah. So my idea here was that once these two PRs are in, we'll pretty much have to either do a runtime upgrade on the testnet, or I'm not sure how we are doing the upgrades right now. Once we get that done, in the meantime, I want to have a chat with Serge to. I think he has already done some of the work as part of his previous task itself, if I remember correctly. But I'll check with him again. But the changes would be pretty much minimal. What we ideally need to do next would be to actually start looking at which blocks to start importing for Polkadot and Kusama, because we do not have justifications for earlier blocks, and we do know which block we can start from, but the thing is we would have to find the authorities that are that actually signed those blocks at that point. So we just need that particular block and then the authorities to actually initiate. And from then on, the relays can start picking up which block to go with after once we start initializing. And then it should be pretty much seamless after that. Just wait for finalized blocks and submit, do a feed put.
Any thoughts on that, Nazar?
Makes sense to me. I don't really have any complaints about that. Seems like a reasonable approach.
Okay. Yeah, if you can talk to Serge, and then on Thursday, if you guys can present kind of a plan for us on next steps and how you'd like to go about it. I think we had decided that we're going to start validating as of the last hard fork of the consensus code. My concern is I don't know if that's going to require us to restart the whole DevNet again. So that means we're going to have to start revalidating that. If so, we might just want to start validating from whatever block whenever we run the upgrade, so that we don't have to restart the whole process again. Maybe that's inevitable. I don't know. But whatever it has the least impact on our current testnet would be preferred.
Okay. So one assumption that I made with this PR is that we would have to start new, but I think that could be avoidable in the sense that we may have to make some changes. But I think I'll know better once I talk to Serge on the relay side, see how he's been thinking about it on that end. But yeah, makes sense. Maybe we can go over the plan during the sync this Thursday.
Okay. Yeah, in general, and we have not done a forkless runtime upgrade yet, right, Nazar? Yeah, so we haven't done this, but this is something that we would love to do and make as our standard policy, so that we have as few breaking changes as possible and as much of our changes get implemented in the runtime versus in the client. We are, of course, going to have some breaking changes. The switch to incentivized testnet is most certainly going to be a breaking change. We'll probably have multiple breaking changes during incentivized testnet. Once we get the mainnet, we're hopefully not going to have any more breaking changes. But throughout that entire workflow, as much as possible, we always want to try to default to a forkless runtime upgrade as how we implement changes.
Yeah, I think that makes sense. Also, speaking of that, Nazar, Jamia, do we already have an endowment account on our testnet for the credits that we can use for testing purposes, or is it mostly just a few folks have access to that? I'm just thinking if we have any faucet or some sort.
We have a testnet account that has some coins to submit transactions.
Okay.
An admin account.
Okay, cool.
But we currently don't have a fee that's implemented for the cost of storage, right? It's optional.
But that's irrelevant, I think.
Yeah.
Okay.
It's mostly about runtime upgrade, whether we can actually do it.
Right. Okay, I guess I misunderstood.
Yeah, and yeah, like I think maybe that's the thing. Like my next question was that like could we, since this palette like this work assumes some kind of the root there, and if I like the best practice usually was to not have a single root pseudo account, but rather have a multisig that sits behind it. Like, is that something that you guys thought about before? Like have a multisig with devs and then do like, yeah, okay, cool. Yeah, maybe we can take the discussion later.
Yeah, I think it's a great idea. If we had like a 2 out of 3 multi-sig, that would be great. If you guys did that before somewhere else, we could just reuse the same procedure.
Okay. Okay. Yeah, we can talk more during this thing and figure out final details.
Okay, thanks, Bud. Ivan, you're next.
Sure, yeah. There's nothing much from my side, but yeah, let me share a screen. So during last week, we finalized the partial replica support. I guess Nazar will talk about more about it. Yeah, there are some flaws which Nazar discovered during last week. I was mostly waiting for his feedback about that and for his PR, which we merged into this one. And after that, we merged it. So another thing which we merged is a new benchmark for plotting. It's actually pretty simple. We just write some amount of data on disk. I mean, we just plot some amount of pieces to disk, and after that, calculate how many time has elapsed. So, and it seems that there are no major regressions from merging the partial replica support. So beforehand, there were some numbers like this from my side. If we don't run like sync command in order to like sync all the data to the disk, so the average number is around 350 megabytes per second. With sync is actually seems a bit more strangely. Yeah, and with partial replica, the average speed without sync is around 300, and with sync is actually 400 megabytes per second. So yeah, I guess that's it from my side. Yeah, right now I'm working on the implementing a logic for checking the maximum amount of pieces on each identity for plotting of the farmers. So I'm actually finalizing it right now. I hope I will send PR today for review. After that, I will move on to implementing multi-replica support. Yeah, that's all I had.
What's the basic plan right now for the multi-replica support? Like, what are the steps or the stages for that?
Oh, actually, we discussed it with Nazar last week, Friday. Yeah, the two stages which we discussed were at first we need to enforce rules of having a max plot, so that there will be some fixed amount of pieces which farmers need to have on each identity. And after that, we will just move on to implementing this simplest form of the multi-replica support. Yeah, I didn't have a thought about how can I decouple different things from multi-replica support yet. Yeah, because
we actually discussed we can do the simpler version first. We just assume that the farmer will have plots of the size of the max plot size from the consensus. And then if they want to occupy more space with the protocol, we'll just divide the space that they allocate by the size of that plot. And we'll just create that many plots. We'll just skip the check how much those plots are actually full. And then the later upgrade will be to actually account for the size of the blockchain. If it's way smaller than the max size of the plot, that will need to create more plots than just division of the size they want by the max size. We'll have to like divide by almost the actual size of the blockchain, then like prune off the smaller plots over time and expand the other ones. but that will be more complex, so that will be later.
Yeah, right. Thanks, Nazar. Yeah, I actually didn't thought about how can we divide this simpler version like into separate pairs, but yeah, it seems like kind of atomar. So yeah.
Okay, so just to make sure I understand, so reward address is merged and approved. The partial replica farming is also now merged and approved. You're working on enforcing consensus verification of this partial replica sector that a node has, which isn't that the same thing as max plot size? That is the replica sector.
It is. Yeah. It is. Yeah.
Yeah. Okay. And you think you'll have that done today or tomorrow, like very soon, to be able to submit that? Okay. So there's a part on so the initial part was on the farmer side. So now this is on the client side, the consensus verification.
It's actually both.
Or is both? Okay.
Yeah, it's there is some small logic on the farmer side, but yeah, it's mostly on the node side.
Okay, and then the next step is going to be the multi-replica farming with this very initial kind of naive version of multi-replica farming. Okay. Okay, great.
Okay, thanks, Ivan. Really happy to see the progress. Lucian, you're next.
A question before that, if I may,
sure.
Related to this. So when I merge these latest changes to Subspace desktop, for now, do we want only reward address implementation function or also support for partial replica? Like a user will be able to slide this many size of disk I want to dedicate to Subspace. Do we want that at the moment?
We can. We'll have to overshoot a little bit in a sense that the size that we specify right now is just for pieces, but there are some supplementary databases which also occupy space. So we'll have to be conservative and say if user wants to allocate 10 gigabytes, we should actually like allocate 8 for the pieces and assume that like some percentage will be occupied by databases before we actually compute it properly. It's just one caveat to the API.
By the way, I just want to ask like whether we can just create some sort of example for a farmer so that we would write some amount of pieces to the disk and just check how much space is occupied and divide by the amount of pieces written. Not written, but stored actually.
Okay.
I mean that would make it easier to calculate like some like the amount which we need to store like one piece at least.
The overhead, yeah. The overhead, we should do something like that. But still, we should be like conservative and like
true.
Use a little bit less than we expect, because if you like replot pieces, there will be some temporary data in RocksDB. We didn't tune it for like space efficiency yet.
Yeah. I mean, we can sort of have we can plot the amount of data occupied on disk, I guess, also, not to see the spikes and everything.
Yeah, eventually what we want to have is we want to pre-allocate all of that space on disk up front, so that we are sure that user will not use that space for anything else, and then like use that for actual storage. It's a little bit an open question from implementation point of view how to do it with something like RocksDB. But this is something we want eventually.
Yeah, and back to your question, Oskin, we do want to implement all of these changes, but we want to do it incrementally. So the first task would be to get the reward address implemented, and then PR, release, publish, test. And then as soon as you've got that PR submitted and Justin's working on testing that, then work on implementing the partial replica farming. So, there should be like a trail of like a day or two. Okay, great.
Great to have confirmation. Thank you.
Yeah, also, please note that that limit is for the farmer. There is still node, and node is still archival node, so it will still eat some space.
Okay, I think it's my turn. Let me share my screen. Oops. An error occurred. Okay, never mind. So actually, last week I have one PR merged to. Oh, okay, sorry. It's still under review. Yeah, that is about the fraud-proof verification on the primary node. The main point of that PR is the newly introduced fraud-proof externality extension, which allows you to call the fraud-proof verification implemented in the STD environment from within the runtime. The runtime is a no STD environment. Like basically, if you want to call a function implemented in the STD from no STD, you use this externality extension. If you want to call the no STD function from the STD, you use the runtime API, basically. Yeah. And the other changes are basically about adding more information to the fraud proof struct, which are necessary to verify the fraud proof on the primary node. For example, the execution freeze and the code data, which is, the extrinsic, basically. There is one comment from Nazar, which is there any chance that we will not call the fraud proof verification function in the runtime in the future? I believe we discussed this before. Nada said, if I remember correctly, Jeremiah, you're not a fan of verifying the fraud proof totally offline. So.
Sorry, you lost me. Rephrase the question one more time.
Okay, sorry. So currently, we verify the fraud proof in the runtime, right?
Mm-hmm.
You submit the fraud proof using an extrinsic, right?
Mm-hmm.
Which has a downside that the storage proof size will be constrained by the extrinsic size limit.
Mm-hmm.
Okay. So.
Okay, I think I understand.
Yeah.
So I believe the way it should work, there's actually two stages of fraud-proof verification. And this is similar to how it would work in like an equivocation report. So there's one stage where that occurs before, like the fraud proof is an extrinsic, and it has to be verified in the client before it can make it into the transaction pool, right? Before like you would like regossip it or rebroadcast out to the network, you do need to verify that the fraud proof is correct. So that would occur in the client. Now, once that fraud proof is included in the extrinsic pool, then some farmer that gets elected should have that in their extrinsic pool, and then they should include that in the list of extrinsics to get executed, and then that fraud proof should get executed in that block, and then all nodes on the network should execute that fraud proof and arrive at the same, result of slashing the executor or reverting the execution receipt header or the tip of the execution chain. So I think we actually need both. We need the ability to do it in the client. That should be the default. But we also need the ability to do it in the runtime.
But why do we need to do it in the runtime if we already verified that the fraud proof is correct? You can just blindly assume that it is correct, kind of like we do with some other things that cannot be verified in the runtime.
Such as?
Consensus logic. Something that like requires a records route or something that needs to be called from the client, like all of that is in the client.
Don't we verify equivocation reports inside the runtime?
That's only because they are stateless. We just have two headers. We just need to compare that they are both signed, but for different equally different content.
I mean, if we do it that way, the trade-off is that we have to have client upgrades in order to change fraud proofs. Whereas
we still need it. Like whether we call it from the runtime or not, we still needed to modify it on the client. It's not implementable in the runtime right now.
Well, we could if we use the same runtime API for the client to verify the fraud proofs even outside.
No. In order to verify it, you need to instantiate WASM with some storage as like the kind of environment, and that thing is also only implemented in the client. So what we do, we are kind of in runtime, but we are calling into the host, into the client to actually do work and get result back. So it's still in the client. We just have like another layer of interaction, which like takes time and basically increases the API surface that we need to maintain forever on the client, between client and the runtime. So if you already have to verify it on the client, which I believe we do, then like what's the point of doing something else in the runtime additionally? Just read, assume it's correct, and just do what you're supposed to do, like slash someone.
Okay, so then what happens if somebody includes, what if an elected farmer includes an invalid fraud proof?
It will not pass block verification during like verification stage or in block import. It will fail on the client to be imported.
Okay, because it won't be recognized as a valid extrinsic.
Yeah.
Okay. Okay, makes sense. Does that clear that up, Lichen?
So the externality extension is not necessary.
I believe in this case it's not necessary. Yeah.
Okay. Anyway, it's not a huge code changes. I think we can merge as is. The other thing is, yeah, I have tested the second attempt for the primary runtime, like including the secondary runtime. Yeah, it works. But about like regarding my solution, which is like looks like simpler, I have no idea why it doesn't work. But I don't plan. I just don't get it. But I don't plan to spend more time like digging it. What is wrong? Like, so I think I'll just go with the another like approach and continue the next steps. Yeah, you know, we have a tight schedule.
Yeah, I'll explain a little bit later what, how, and why.
Okay. Okay. Yeah, that's all my head.
Yeah, we also discussed that there is this potential for compact fraud proofs, where the fraud proof on chain will only include like the fact that there was some fraud, but without the actual storage, because it, like storage proof, because it's kind of derived anyway, like it's not new information. So the client will verify everything, but only like the header basic of that will be included on chain. So we are no longer limited by the transaction size for the amount of storage that a transaction like or a state migration can actually use.
I just had another thought on not doing the fraud proof in the runtime. What if we're syncing a node?
We'll have to assume that those fraud proofs are correct.
So we can't have a trustless sync anymore?
We can if you're executor. If you're executor, then you can like call from one client to another and like give me a proof for like, or give me the correct storage transition for this thing, and you can verify it against the incorrect one. So you still have access to that information, but if you are like the farmer, then if you're syncing 10 years later, does it really matter? I'm not sure.
Well, it probably doesn't matter from a point of view of like in the honest case, but there could potentially be an attack vector where you could generate a fake chain that had an invalid fraud proof and a farmer wouldn't be able to distinguish between the two chains.
Right, but we also assume that then that chain will not be longer than the honest one, right? Just because most of the storage should be on the correct chain. So.
Okay, but if you do have a dishonest majority of storage, I mean, that's the whole purpose of the fraud proof in the first place is to protect live clients in the case of a dishonest majority. Okay,
let's probably discuss it once we get to that. That was just one of the idea. Right now we are not doing compact version, so everything is just the way it was before.
But would that still not apply in the case of just the fact that we're not verifying the fraud proofs in the runtime?
I think it's irrelevant.
Okay. So I guess if we sync a block and then as part of the block import, we're checking the transactions before we apply them?
Either there or in verification, it was like two distinct stages. I will explain a little bit later because I hit the problem there.
Okay. All right. Okay. Okay, we can talk about that later. We might want to actually discuss it with Srivatsan as well to get his thoughts on that.
Yeah, definitely.
Okay. Liu Cheng, just one quick question. So this should implement fraud-proof verification on the primary node. Are we waiting to merge some PRs before we can actually test that?
Yeah, I already tested.
Okay, so we have a test case for that and it works.
Yes.
Great. Okay, and then what are the next steps after all that is merged in?
Is to let the executor fetch the runtime codes from the primary chain instead of its local storage.
Okay. That should be pretty straightforward, right?
Maybe not.
Okay.
Maybe
You think so, but
maybe some substrate changes are required. You know, I'm not sure.
Okay, great. Okay, sounds good.
okay, let me share, and I hope my audio will not disappear, but we'll have to try. Okay, can you see it?
Yeah.
And you can hear me. Awesome. Yeah, one was the first thing was the fix to the partial replica. I guess I explained very briefly. So the very root of the problem is not very obvious. We had the old API for writing pieces. Is this a test? Yeah, this is a test. I need the plot itself. Plotting.
Should be above, no? Just go above.
Oh, the rest.
No.
Okay, yeah, collapsed. So we had an old API which worked fine when we have contiguous ranges of pieces, so to speak. And we were writing them in a way that required us to specify the first index. So this is like a range. However many there are, they start at this index. So like if this is piece index, let's say 10, then 10, 11, 12, and so on. However, right now we are filtering those pieces because not all of them are actually going to be included in the eventual plot. Some of the reasons for that might be the max plot size. So like some of the pieces just outside of our range from what we've like plotted or received over the network. So we have to drop them, and our range is no longer contiguous. We can just receive pieces in random order. So we need to specify the array or like vector of those things explicitly. And basically the code was not accounting for that. And there were two side effects. One was that they were plotted incorrectly. So when you later try to retrieve a piece by index, you might retrieve a different piece. And also commitments were created incorrectly as a result of that, such that when you actually solve something you think you've solved, but the proof will not verify even locally. So I had to like make this API change, and I had to change the data structure that we return to include both pieces and offsets separately, so we can actually like commit them properly back once we're done with the plotting. That is very briefly what happened. Everything else was done by Ivan, so this is just like a fix on top of his work. Okay. That's we just in nightly version, and by the way, it was already fixed in the latest nightly, the issue with the ring library. Then I was trying to combine runtime. Basically, the idea was to create a new crate called Subspace runtime and rename the old ones to something different, and basically include our existing runtime as just a module. Eventually, it was even cooler. Runtime lib. Okay, here. No, this is not the one. Oh, well, I cannot find it. Basically, the idea was that, yeah, here we just have two modules, and we can re-export them at the same time. But the problem is that those are compiled to WASM, and there are some functions which are kind of global. Let's say core version. It's like a global C function kind of exploits from the library. And it turned out that whatever is the latest one just overrides functions exported from the previous one, and those from the previous one are silently erased. So there was no compilation error, but it wasn't actually working properly. And there are also some link arguments that are exposed that are getting into WASM sections that the runtime or like the client, Substrate client can later retrieve without instantiating WASM. And those were also like, those were actually extended. So end result, the WASM binary didn't actually include the runtime, two runtimes. It was including like a mix of two runtimes, which is partially broken. So once you run it with the native runtime, which is still present, it works. But if you switch to WASM, it's like horribly broken in many different interesting ways. So I had to revert that. And then I have implemented an alternative, which is this one, where the way runtimes are built in Substrate, they have this build script that is called that calls the Substrate WASM builder, and that basically creates a new crate in a temporary folder, and it links as a dependency into the crate that you actually have as a runtime, and it sets some features, and then it compiles it separately, and then it proceeds with compiling the actual like original crate, and it might include some of the code from there. That's basically the way they have WASM built, and then include it into the native runtime. They have like two-step process. It's actually quite tricky the way it works, which required me to build this monstrosity. Basically, we have Subspace WASM tools, which has a new function exposed. We can specify the target, just target of the project where the dependencies are and everything is built. Then you can specify the name of the crate of the runtime that you want to include a WASM for. You can specify the constant, how it will be named, and where you want to, how you want the file to be named. And then in something like Subspace runtime, you can actually call it from the build script as well. And you can get this execution WASM bundle file, which will include, in this case, parachain template or like secondary runtime that you have. And then in the runtime itself, you can have this thing, which will include basically secondary runtime both in WASM and non-WASM environment. So our WASM bundle got bigger from like 1.1 megabyte to 1.6 megabyte because it physically includes both runtimes completely separately. It's not like the same level where all of the functions are in the WASM. This is like one WASM inside of the other WASM, like just like as bytes. And that fixes all of like compatibility problems, but it changes the API a little bit. And the API is basically like this. We have a new runtime API function that we can call, which will get us access to the memory of the WASM blob. And we can then instantiate it with WASM VM or whatever we want to do. Yeah, I guess this is.
Question on the upgrades though, like how do we see the upgrades working for the built-in versions if you want to?
Yeah, so the idea is that we will only have one upgrade on the primary chain, and that will imply that secondary runtime is also upgraded. So the secondary like execution will basically have to follow the primary one. Once it notices that something needs to be upgraded at a particular height, it needs to call this runtime API, extract the blob, and replace this blob at a particular height in sync. One slight alternative to the way it's done right now could be, right now we include this constant, which is called execution WASM bundle. We can actually replace that and put it into the WASM sections the same way that the like runtime APIs and version is included in WASM. that I mentioned, like global thing, that will allow us to not instantiate runtime at all. You just get it from WASM bundle. I'm not sure if it's beneficial or not, but this is something that Luchain already does in his code when he retrieves the code for the primary runtime. So if you don't want to instantiate that just to get the secondary runtime, we can actually just parse it and extract a section without like going any deeper. So that will be like one potential change that we might want to do here. That will like I'll see what Luchain did in his branch once it's ready, and then we'll probably discuss the pros and cons of those approaches.
Just one comment. So from what I understand, Subspace WASM tools can be done using Substrate WASM builder, right? It's just like to read the artifact produced in the build stage, the WASM file, like into this execution WASM bundle file. Right?
Yeah, kind of. It's kind of possible, but there are some. I think it boils down to the fact that it will build it twice. Is what I'm trying to say.
Yeah, I get it. So, I mean, if we're going to like manipulating the build script, then we don't have to add the library to the dependencies. So I guess it won't be built twice. You know, my understanding is that my approach, the difference like between your approach and mine, is that there might be some magic in the WASM builder feature gate. Is that possible?
Yeah. Oh, okay. Let me explain that. Yeah. That's an interesting one. So in the parachain runtime, yeah, basically I've added a new feature, which is WASM builder, which is not enabled by any of the dependencies or like dependents. It is only enabled in this script specifically. And the goal of that is in here to make sure that we include the actual implementation only when that feature is enabled or when we are in STD environment where we don't have those like global C functions exposed. Otherwise, we are not including this. So basically, in the in Subspace runtime, when we are depending on it, it will not embed those global things and will not override anything. So I think it's a little bit orthogonal to the problem that you have, Luchain. I think you're just like, it's really convoluted the way it like when and how it calls those build scripts due to like new temporary directory created. Because like if you're building a parachain template runtime, it will run a build script, but then also it will create another folder. It will create another cargo toml there that points to the same source, and it will also call the build script underneath it. So it's like recursion basically. But at some point it will stop by like internal check. But it's kind of a mess if you go into it. I think we will simplify it later. This is just like one of the simplest ways I found it to actually work, and then we'll probably.
Okay, makes sense.
Yeah.
I just like I can explain like what's wrong with like my approach. I can tell.
Yeah. Okay. Sorry. I need to share my screen again. We are running a little bit behind time. Jeremiah might need to switch over if you want. There is just one.
I'll let you know that we'll be late, but it's, okay. We need to finish up here.
Yeah. So there is this pull request I opened today. I just want to explain what's the problem here. This fixes this strange issue which wasn't really reproducible. That basically results in like block import errors. Might look like this. Might look like this. No, this is not the one. These ones. And we had like a few reports of these related to inherence. Basically, I submitted a question on the new shiny Substrate beta Stack Overflow. with my ideas, and they turned out to be correct. Basically, we have this verifier that is provided by SC consensus import queue that actually can verify the block. But we also have another thing, which is block import, that also have some verification in its implementation in the method. And I was a little bit confused, like what verifications needs to be done where. It turns out this verify is actually not guaranteed to be running on the block that has its parent imported. So it's basically needs to be like a stateless kind of verification where you have some information in the header, and you can verify that that header actually makes sense, that it's signed properly, but you cannot really like verify the difficulty because you don't know what was the difficulty as of the previous block, because that block is not guaranteed to be imported. And sometimes it's important, so it works most of the time, but sometimes it's not. And then it suddenly breaks in very hard to explain ways. Basically, we've inherited some code from Babe originally, and there were a lot of verifications there that actually shouldn't be there. They just didn't get to fix it. And I extended them with even more verifications, and some of those verifications relied on root blocks, which need to be archived later, so like it broke horribly in some cases. So the first commit was here to just refactor it. Basically, I took all of the verification logic from the import block method, this one, and just took it out. So basically, it's no longer here. We just call into the import block verification function in the same struct. I just have it above. And that was done in order to extend it later. So two other commits are basically taking some of the verification out of the verifier implementation. So for instance, we were extracting global randomness and comparing to the randomness included in the header, whether they match. If not, that you included incorrect randomness. And then the same for solution range and salt. Those were moved. And then I also moved the records root check in there as a first step. We also had a verification check header function. And that one was checking things, including piece correctness, whether the piece is actually part of the history. But since we don't know the root block, we cannot verify that particular piece of information, but we can verify everything else. So I refactored this struct a little bit to have the piece verification optional. So basically, piece check parameters are some or none. If some, we do verify the piece. Otherwise, we do not verify the piece, but we verify everything else. So we verify that the tag is correctly generated, the local challenge is derived correctly, and all of the like solution range, according to the header at least, is valid. So like we do everything we can statelessly. We do not reach out to runtime for those. And then our root blocks are actually inherents. So we actually had two verifications for them. One was written by me manually, and the other one was actually done in the verification. So what I did here is I removed the logic of inheritance verification from the verifier. So this is where we have the subspace verifier. We had this function, check inheritance, and then we had this a little bit of supplementary logic here to actually construct this thing and then call. All that is removed from here and moved instead into the block import verifier. And also, as a result of that, we had this logic where we were extracting roots from the root blocks data structure, which is like a LRU cache. We no longer need it, actually. No, not this one. This one, we were actually going through extrinsics in the block. We were finding the inherent, which is with root blocks, and we were comparing it contents. That's actually implied by checking extrinsic inherents in general. So we're just checking inherents here. The kind of the way it was done in verification, this is like gone. And there was a lot of logic around generics. Generics are pretty scary here, the way it's done in the Subspace service. So like there is a little bit of a mess here. I actually simplified quite a bit with just impl. When I was trying to specify the country type, it was just like 4 levels deep generics. Eventually, I made it compile, and now the I can just show the result. Yeah, okay, I need this, the whole thing. And when we go to the lib, very far, okay, Subspace verifier. We no longer have enhanced check, and basically our verification is very simple. We just decode the pre-digest. We check whatever randomness is in there. We don't know if it's valid, but at least we will verify the rest of the header according to this one, and then we'll verify whether this is correct in the block import. So we basically extract some parameters and we verify them statelessly. We don't have anything to verify the piece itself, and then we just move on. And we don't have any inherent verification here. We do still verify the equivocation. I'm not sure we should do it here. I'm not sure if this is actually guaranteed to be running in one instance, but in other words, we do not verify multiple blocks concurrently. This is a question I have in the matrix. I'll probably move this particular thing into the block import as well. Otherwise, it's like a relatively short function compared to what was like 300 lines or something. So that should fix this strange issue where sometimes root blocks are there, sometimes they are not, and it's like not clear what's happening even. Yeah. And this is why I was saying that some of the logic for verification needs to be in the verifier and some of that needs to be in the block import. So depending on whether the fraud proof is actually stateless verification of it, we might put it in one or the other implementation. And the same actually for Ivan's enforcement of the max plot size. If you need runtime access for the current max plot size, then you probably need to put it in the block import check.
At what stage in the import pipeline is the block broadcast to peers?
I think it's only verifier that is checked before broadcasting further. I think so, but don't quote me on that.
And what are we checking in the initial verification again?
We are checking that information in the header about solution makes sense according to global randomness solution range and salt included in the header itself. So like locally. And we'll check whether those values are actually correct once we have the previous block imported.
So it's like a Spartan proof of space verification?
Yeah, kind of, yeah. That's
Okay.
a good way to think about it.
Okay, so I'm just trying to think of like what the worst attack you could do if you could propagate an invalid block across the network.
Whether, as Bastian said here, basically the idea of verifier is to check block in isolation. And for proof of stake, you just verify the seal. That's like all you can do. You don't really know the up-to-date authority set unless you have the previous blocks imported. So I think this is kind of the way it's designed to work.
But if we're not checking equivocation, does that mean that we're going to broadcast?
We do check equivocation here.
Okay, all right.
I don't think we need to remove it, but we'll probably have to duplicate it in the block import if it's not guaranteed to be non-racy. If it's non-racy, that's fine, but I don't have confirmation on that.
Okay.
Yeah, that was an interesting journey of discovery, but I hope it makes sense for everyone and you learn something. Okay, that's all I have, unless you have any questions. Awesome. Thanks, everyone. Next time we'll have 90 minutes, I think, and we'll have a little bit more time to discuss all of this. Thanks, everyone on YouTube for watching, and we'll see you next week.